Hello class, this is the second set of examples on multi-step equations with algebraic denominators. So let's get straight into it. Now, previously we saw, and we could easily identify that the lowest common multiple between these two numbers just becomes 5x. And in this one, we can see that we're just comparing the 3 and the 7 to get 21. However, now we have grouped or more complex denominators. Now, we still treat anything here with a denominator of 1, and we're still searching or still thinking about the lowest common multiple. Whenever we have these more complex denominators, we actually just multiply them as a group. So this becomes 2x plus 1 times 2x minus 1. So our lowest common multiple is the product of these two groups, and we just leave it like this. Now, the same idea applies. Just follow along now here. This time I'm going to color code everything so you can hopefully simplifies the understanding. For 2x plus 1 to become this denominator, notice we are missing the other factor. So we are multiplying this denominator by 2x minus 1. Well, since we multiply this denominator by 2x minus 1, we multiply the numerator by 2x minus 1 as well. So for this, I'm going to take every step along the way. We write the 3, we copy it down. We now write as a group 2x minus 1. We now take a look at that plus. We keep that there in the front, plus. And notice how this hasn't changed. So we're going to copy that down as well. So 2x. Same idea now. Let's use a different color. For 2x minus 1 to become this denominator, it's missing the other factor. So we're multiplying this denominator by 2x plus 1. And so we multiply the other numerator, well, the same numerator, by 2x plus 1. We already have that 2x. And so we write as a group 2x plus 1. We carry the equals. Now it's going to be 1 times, and notice how this number 1 on the denominator is missing both factors. So we're going to write both the factors up top. So it'll be 1 times 2x plus 1 times 2x minus 1. And now, just as we did in the previous step, since everything has the same denominator, we multiply by the denominator and it goes away. In the exact same way, we are multiplying by this denominator and this now goes away. So in reality, we have just this as our problem. But leaving that there so we can see where it's coming from, we now expand the numerator. So expanding this, 3 times 2, 3 times negative 1. Those two become 6x minus 3. And expanding this as well. So 2x times 2x. So just paying attention, 2x times 2x. That gives us positive 4x squared. 2x times 1 gives us plus 2x equals, and we expand this group as well. Okay, so following along again, 2x times 2x, that will give us, let's do this using colors, those two become 4x squared. In green, 2x times negative 1 is negative 2x. In red, 1 times 2x is plus 2x. And in dark purple, 1 times negative 1 is negative 1. So we are now up to this step. If you actually notice from this point forward, it's actually pretty straightforward. We are collecting like terms, so 6x and 2x. Those two collect to become 8x. This negative 3 on the left-hand side is on its own, so we can write this as negative 3. Notice how I'm not even writing this one. The reason for that is from this step, if we have plus 4x here and another positive 4x, these two will actually cancel on each side of the equation. So that's exactly what I'm doing. These two now cancel, and everything on the left-hand side has now been collected. So again, these two become 8x. The negative 3 is here, and the positive 4x squared cancel with the other 4x squared on the other side of the equation. And again, notice these two will also cancel out. So negative 2x plus 2x, these two cancel, leaving us with just negative 1 on the right-hand side. So this mess simplifies down to this nice, neat equation here. And so we just solve this equation as we normally would. This becomes 8x equals, adding 3 to this side, so plus 3 minus 1 is 2. Dividing both sides by 8, 2 over 8 simplifies down to 1/4. That's a full explanation of how you would tackle a problem such as this. Now you can pause and try this next one yourself as well. It actually follows the exact same logic, just with a slightly added difficulty of this negative 2. So you can pause and give this a go yourself, but here we go. So when we have two complex denominators, or ones with groups, we just multiply the two. So I'm going to write this as x plus 4, 3x plus 5. For this group, for this group to multiply to this complex denominator, it needs the other group. The complicated part of this is now we have this other group. So take a look. I'm going to color code it. X minus 3. And this becomes 3x plus 5. I'm going to copy down the negative 2. So we've copied that. And same idea for this group to become this entire group. It's missing the other factor. So let's do that in light purple. So we're missing the factor of x plus 4 equals, and again for this one we just have the 1, so both will copy, or both are multiplied to here. Notice how for this I'm not bothering with the 1 because 1 times everything is the same thing. Now for here we carefully expand these groups. So here we go. X times 3x is 3x squared. X times 5 is positive 5x. Negative 3 times 3x is negative 9x. And negative 3 times 5 is plus 15. We are finished with expanding this group. We are now going to expand this next group, which is a lot easier. Negative 2 times x is negative 2x. Negative 2 times positive 4 is negative 8. And we're finished with this expansion. Likewise, we just expand this again. X times 3x is 3x squared. X times 5 is positive 5x. We're finished with this expansion. We now look at 4. 4 times 3x is 12x. And 4 times positive 5 is positive 20. And I hope by now you can see that because we're up to the step where everything has the same denominator, I've already just ignored or just multiplied that out and went straight to the expansion. Now from here, it's just a matter of collecting like terms and canceling out any that are present in both the left and the right hand side. So for this, 3x squared and 3x squared are on the left and the right of the equation. So those two cancel. You can ignore those. We can collect like terms of the x's on the left-hand side. So 5 minus 8 minus 2. That's going to be 5 minus 9 is negative 4. Minus 2 is negative 6x. So we're finished with collecting the like terms of x. And we now do positive 15 minus 8, which will give us positive 7. And we're finished with the left-hand side. We've already canceled out the 3x squared, so we just collect these two. These two make 17x. And the 20, thankfully, is just on its own. And from this point, I hope you can notice that this is just a regular linear equation. For this, I'm going to move the negative 6x to here. That gives us 17 plus 6 is 23x. And I'm going to subtract 20 on this side. So 7 take away 20 is negative 13. So from this point, we just now divide the 23, giving us negative 13 over 23. And I know that since both these numbers are prime numbers, it's definitely not going to simplify. And that is the answer to this equation. I hope you're noticing that these problems get slightly more complicated, but as you can see, with just careful focus on individual parts of the equation, it's not as hard as, or I hope it's not as hard as it initially was. So I hope to see you in the next video where we tackle the next example. Hope to see you then, and best of luck.